Hello guys, welcome to my YouTube channel. So this is another edition of Calculus with Analysis chapter 4. So guess what we are going to do today? We're going to talk about function. That is, we're going to talk about transcendental functions, monotonic functions, odd and even functions, and more. And with this, we have some explanations and with some solved examples. So please make sure you watch this video to the end, and also kindly check the subscription button and subscribe for more videos. So let's go. So now when we talk about a function is a row function. It's a relation which takes element from a point set D, which is the domain, to element to another point set, which is the codomain, such that each element in the codomain or the domain has exactly one image of the codomain or the domain. So with this, we did this in, I think, SHS. So actually the domain are the functions, or they are the interval that makes the function exist. Any number which is a row number of the domain is called independent variable, right? The function may be represented in this form. So functions can be represented in this form. So the x is representing the independent variable and the y representing what? The dependent variable, right? So note, the domain of a function is also defined as the all set of real numbers for which the function is defined, as I said, right? So we can represent this as that. So when you write this, it means that the y is the dependent variable and the x is the independent variable. Let's get going. So we're going to look at some forms of functions. We have the graph of functions. So the graph of functions is a pictorial representation. So some functions can be drawn using the graph, right? So we can represent a function using the graph. We can get the curve or what you know. This representation may be on a rectangular coordinate system, and the point may be defined as xy or x f of x. So you can get the cylindrical coordinate system or the spherical coordinate system. Now, the one we're going to talk about is the bounded functions, right? Some of the functions are bounded, which means that they have their limit, which is the upper bounds and the lower bounds, right? So with this, let's read this. So let S be the element of A and B. With my previous video, we talked about this. This is a closed set. It means that A is closed and B is closed. So if there is this M, which is a real number, such that M is greater than or equal to f of x, then f of x is said to be bounded by the above, which is the capital M, which is the upper bound of M. So with the bounded functions, let x be a subset of A and B. Now with my previous videos, we talked about the bounded functions. Now we talk about the bounded set, right? So we have the closed and the open set. With the closed set, it is enclosed with what? A square bracket, and with the open set, it is parenthesis. So what this one means is that if there exists M such that M is greater than or equal to f of x, which is an element of A and B, then f of x is said to be bounded above, with the M being the upper bound of f, and we have the M being the lower bound of f. So now we have something here. If let's look at this. Please pay attention to this. If f of x has an upper bound, it has what? A least upper bound. And if it has a lower bound, it is what? The greatest lower bound. Let's take one example. So let's take this example, which is that consider the intervals. They gave us a closed interval with -1 and 1, and they are asking us to find the upper bound and lower bound, right? Now let's look at this. The function f of x, which is equal to 4 minus x, is bounded above by 5, or any number greater than 5, and it's bounded below by 3, or any number less than 3. Let's see how it is done. So let's take the interval of -1. So when we take -1, we know that when you insert -1 inside the function given to us, we're going to get 5. And when we take +1, when we insert it, we're going to get what? 3. Now, from what we did, which is the upper bound and the lower bound, note that the 5 is the least upper bound because it can be what? Any number greater than. So from 5 becomes the least upper bound. Are you getting it? Yes. And with the 3, it becomes the greatest lower bound. This is because when you are moving less than 3, the 3 is the highest one. That's why we call it greatest lower bound. So from this 5 and 3, the 5 becomes the what? The least upper bound is now what? 5. And the what? Greatest lower bound then becomes what? 3. Because the least upper bound, there can be a number which is greater than 5. Because 5 is the least. But when you go to the greatest lower bound, from 3 is the greatest. You go to 2, 1. That's why we have the least upper bound and the greatest lower bound. So you should know that. And the trick is that you just look at the upper, that's the highest number, and lower is the lower number. So just understanding this will help you do that. Now let's go to the monotonic function. A function f of x is a monotonic increasing function in the interval which is closed like this. So with a monotonic function, we have monotonic increasing and monotonic decreasing function. What does this one mean? So when you talk about monotonic increasing function, it means it's increasing. When you give a function, you put the intervals inside. It increases from the lowest to the highest. So 1, 2, 3, 4, 5. But the decreasing is starting from maybe 10, 9, 8. Note that the monotonic increasing function can be also known as the monotonic non-decreasing function. And with the decreasing function, we have monotonic non-increasing function. You should know that. So let's take an example. So we have the function f of x being equal to what? 2x plus 1 is a monotonic increasing. So we need to show that this is a monotonic increasing function or monotonic non-decreasing function. So whether you are going to put the interval inside. The interval is from 0 to 1. Yes, so let's put 0 inside. When you put 0 inside, we are going to get, when you put 0 here, from here, we are going to get 1, which is this. So we are going to get 1 for this. And when you put 1 is, you're going to get 3. So it means that it is increasing because when you try for 0 0.1, 0 0.2, it will start from 1 and it will end as 3. So 0 0.1, it's going to give you an interval between 1 and 3. So for this, please kindly comment the least upper bound and the greatest lower bound on the comment section. Yes, I know you've done that. So with the greatest lower bound, it is 1 and the least upper bound is 3. Let's get going. Let's take this question too. We have another example. We are supposed to show that this is a monotonic decreasing what? Interval. We know that the interval given to us is 1 and 3 and it is closed. So when you put 1 here, you're going to get what? 1, right? And when you put 3 inside, you're going to get what? 1 over 3. So it means that this function is decreasing to somewhere. So it is decreasing to 1 over 3. So it is a monotonic decreasing order. It's very simple when you put the values inside. Now, with the question number 1, we've done it, right? Now, let's take this question 2. We are supposed to determine whether it is monotonic what? Decreasing. You are supposed to put the values inside and see how the thing is what? Going. If it's starting from the lowest to the upper, that is from 1, 2, 3, it means that it's increasing. When you do that and it is from the highest to the lowest, it means that it's what? Decreasing. That shows that it's monotonic decreasing and monotonic increasing. So with this, you are going to put the intervals inside to note the difference, right? Yes. So when you put 1 inside, you're going to get 2 over 1, which is 2. And when you put 5 inside, you're going to get 5 plus 1, which is 6 over 5. So it will be decreasing, decreasing. So that's why we say it's a monotonic decreasing order. It's a monotonic decreasing function. So let's consider these two. We have another function. So with this, we are supposed to try the boundness and also the monotonicity. So with this, you know the boundness, the upper bound and lower bound, you're supposed to find them. When you put 0 inside here, you're going to get 0. And when you put 1 inside, you're going to get what? Let's see, you're going to get 1. You're going to get 1 point, is it? 1 over 2. So you're going to get 0 0.5. So you're going to get 0 0.5. This means that this whole thing is increasing. So it is monotonic increasing order. because it's increasing, and it is bounded by the upper bound is the least lower bound is 0, and the greatest lower bound is 0, and the least upper bound is 0.5. That's it, and it is monotonic. This is a monotonic increasing order. Now we are moving on to the type of function that we have. We have the polynomial function, the algebra function, and the transcendental functions, right? And I'm going to add another one, which is the even and the odd function. This is very important to know the difference between the even and the odd function. So let's get going. So with the polynomial functions, we have a polynomial function can be expressed as this. And one thing about this is that, let's read it. This is called polynomial in x of degree of n. Then this n is the degree, right? So let's note this. Every polynomial equation f of x is equal to 0. Then if it's equal to 0, then it has at least one root. And if p of n of x is equal to 0, then it has n roots. Yes, so let's take an example here. Wait, let's look at this before we go to the example. We have the algebraic functions. Any function y is equal to f of x satisfying an equation in the form of this is an algebraic function. So where p naught and n naught are polynomials in x is called algebraic function. If an algebraic function may be expressed as a quotient of two polynomials. So this, you must know this. Let's go to the transcendental functions. With the transcendental functions, these are functions where deals with the logarithmic functions, the trig functions, and the exponential function. But before then, let's do a question on the polynomial. I want you to find the degree of this. What is the degree of this? So comment in the comment section to tell me the degree of this. Now the degree of this is 4 because the highest exponent is 4. That is the degree. Let's move on. So we have some examples of the algebraic functions, right? Yes, some examples of the algebraic functions. Now let's go to the elementary transcendental functions. So as I told you that the transcendental functions comes in 3 ways. We have the logarithmic functions, we have the exponential functions, and we have the trig functions. So now let's go to the exponential function. You know that the exponential function is f of x is equal to a exponent x, where a should not be equal to 0 or 1. You should note that. And the number 2 is the logarithmic function. As you know that f of x is log a, that's log s to the base a, and a should not be equal to 0 or 1. If a is 2.718 is equal to e, then we can find the natural logarithm, which is the log. So the natural logarithm is a natural log what? Is a log to the base e. Is the same as ln x. So you should note that. So log to the base e is the same as what? Ln x. Let's move on to the third one, which is the trigonometric functions. The trigonometric functions are the circular function, which is the sine, the cos, the tan. And these are also, they also have their reciprocals, right? So we have some things that we need to know. These are things that you must know, that sec s is equal to 1 over sine cos x. Cosec s is equal to 1 over sine x. These are things you must know, very important, because sometimes evaluating this with respect to, that's when you go to differentiation. With this topic, you move to differentiation. So with this, it can be the basis of differential equation and also differentiation, because certain differentials, you can express them like this before you differentiate. So you need to know these identities. We call them the trig identities. So note this. You know, sine squared plus cos squared is equal to 1. These are also trig identities that you need to know. They are very important. These are very important trig identities that you need to know. And also this, because it will help you evaluate some trig properties and some trig questions, and also help you to differentiate and integrate some trig questions. We have another identity. Now, when we talk about the inverse of trigonometric function, sine inverse of x is the same as arc sine x. So arc sine is, whenever you hear arc sine, ARC, it means that's what? Sine inverse. So ARC, that is ARC of cosine is cosine inverse. So if I ask you to find the arc sine of 1, you are supposed to do it. It's the same as cos inverse of 1. You should note that. And we have also the cosec inverse and the sec inverse. These are all identities that you must take when it comes to the trigonometric functions under the transcendental functions. This is the thing, the odd and the even function. Please, let's pay attention to this. It's very confusing sometimes, but I'll make sure that I break it down for you to understand very well. Now, let's go. A function is said to be even if let f of negative x is equal to what? F of x. So it means that when you find the negative of the function, you should get a function back. When you find the negative of the function, you should get the function back. So let's go to the odd function. A function is said to be odd if when you find the negative of a function, then it's going to give you negative of the whole function. So with the even function, when you find the negative, you're going to get positive function. But with the odd function, when you find the negative, then you can bring the negative out and take the function. So you are going to negate the function. Let's take some examples for you to understand this. So let's take that. They say what? X squared, right? It's an even function. Why? Let's see something. When you put this function, whenever they ask you to find the even function, you're supposed to find the rule first. So we know that the even function, this is the rule. So they are going to do substitution. You are going to put in negative x. So let's put in negative x here. Negative x squared. You know that negative x squared is the same as x squared. Because when you put negative 2x squared, this is 4. That's all in bracket. It is 4. And 2 squared 2 is 4. Therefore, x squared is what? An even function. We are doing substitution here. We put the negative x, because first it's always like this, so we need to therefore substitute the function with negative x. Then we put negative x here. That's what we did here. We put the negative x here. Then this is the same as this. Therefore, this function is an even function. We'll be doing more example. Let's go to the odd function. This function is an odd function because, let's see something here. We know the odd function, when you find the, when you put in negative, when you find there's a function with respect to negative x, you should get negative outside and the whole function again. Let's see something. Look at this. So we are inserting the negative x inside. That means you're going to get negative x or exponent cube. And this is the same as negative 1 cubed s cubed. And it's going to give you this. So it's similar that we have expressed this as that. So with the odd functions, when you substitute the negative into the function given to you, you should get the negative of the original function. That's why we had the negative. You see the same function is here. And we had the negative of the original function. But with the even function, you should get the same function. If you don't get the same function, and also you don't get it like that, we have functions which are neither even nor odd. Example is x squared plus s cubed. Let's take more example. Note that if f of x plus f of negative x, you get even function. And when you subtract, you're going to get odd function. Put that in your head. It's an identity. Let's take something with a transcendental function. Note that sine is an odd function and cos is an even function. Take your calculator. Let's do this. Take your calculator and type in sine 45. So now let's type in sine bracket open negative 45 and close it. Punch the answer. Now take the same calculator and write negative sine bracket open 45 and check if the answers are the same. That means that sine x is an odd function. Now let's go to cos. Take your calculator, type in cos 45 and also type in cos, then bracket will be negative 45. You will see that they are the same. It means that cos is an even function. Take that. Now let's prove this. So we have an example here. Wow. So now let's say prove that the function of x exponent 4 minus 2x squared plus 3 is an even function. Let's prove that. So first, we know our identity. So we know that our identity is this for even functions, right? So we need to know this. Please note this one. So when you take that, let's substitute it inside. So when you do the substitution, this becomes negative, right? That is negative bracket open. So you bring the bracket, negative x exponent 4 minus bracket open, negative x squared this. Now note that with the the even function, it means that we must get the same function back. When we use this, we should get the same function. So now let's do this. You know that this bracket open negative x exponent 4 is the same as x exponent 4. So we don't change anything. And note this, negative x bracket open all squared is the same as x squared. So at the end, you are going to get the same function back. This means that what we've done here is an even function because we had the same answer, or we had the same, our answer is the same as the question given to us. So that's the whole idea about the even function. But with the odd function, let's take another example for the odd function. Let's prove that this, okay, let's take this. So please prove this question to see whether it's an even or odd, and comment in the comment section. No, I know you've done that, so let's go. So with this, let's do some substitution. You know that with the sine function, or with the odd function, this is the expression. That means that at the end, we should get negative of this whole function. So let's do the substitution. When you do substitution, you know that this is going to give you negative s cubed, and this is going to give you, this multiplied by, it will give you plus 4x. So at the end, you're going to get something like this. Then if we're able to express it as a negative of the function, so we're able to express it as the negative of the function. So this is the function given to us, f of x, right? And now we've negated. That means that this function is an odd function. As very simple as that, because you're able to express the function and negate it. This is a function which is this, and now there's negative outside. Therefore, it's a what? An odd function. You can try this too. Now we know that we've done some absolute value on this. We've done absolute value. Now, absolute value of a negative number is the same, is positive, right? So let's see this. Now let's do some substitution here. You know that 3 brackets will be negative x squared is the same as what? 3x squared. And the absolute value of a negative number is a positive number. So absolute value of x, that's absolute value of negative x, is the same as x. So when you do that, you're going to get a what? Function back. That means that we had the same function back. That means that this is an even function. So thank you very much for watching this video, and I hope you like this video. You can try your hands on more questions, and if you are finding it difficult, you can comment on this video so that I can give you some answers. Now, please kindly subscribe and like, and I hope you also like the video. Kindly share with your friends and watch out for chapter 5. Thank you very much.